Imagine standing at the edge of something so vast that your mind struggles to give it shape. You know it exists, you know it's real, but its scale feels abstract, almost unreal. That is how most people experience the deepest parts of the ocean. Not as places, but as ideas. For centuries, the ocean was mapped only at its surface. Early explorers traced coastlines, measured currents, and named seas, but what lay beneath remained invisible. Sailors knew the ocean could be deep, but they had no way of knowing how deep. The darkness below the waves became a blank space in human understanding, filled with myths, monsters, and imagination. Even as science advanced, the deep ocean resisted exploration. Light disappears quickly underwater. At just a few hundred meters, sunlight fades into darkness. Beyond that point, human senses are useless. No horizon. No reference. Just cold, pressure, and silence. And yet, curiosity persisted. By the late 19th and early 20th centuries, scientists began asking a simple but unsettling question: how deep does the ocean really go? Early measurements used weighted ropes dropped from ships. The rope would fall, meter by meter, until it stopped. But these measurements were unreliable. Currents bent the rope. The ship drifted. The rope stretched. Results varied wildly. Still, one thing became clear. Some parts of the ocean were far deeper than anyone had imagined. In the western Pacific, early soundings suggested a massive depression in the seafloor, a trench unlike anything else on Earth. As sonar technology improved during the 20th century, the picture sharpened. Sound waves set downward took far longer to return in this region. The ocean floor wasn't just deep. It plunged dramatically. This place would later be named the Mariana Trench. At its deepest point, known as Challenger Deep, the seafloor lies nearly 11,000 meters below sea level. That number is difficult to grasp. Mount Everest, the tallest mountain on Earth, rises about 8,800 meters above sea level. If you placed Everest inside the Mariana Trench, its peak would still be more than 2 kilometers underwater. But depth was only part of what made this place extraordinary. As scientists calculated the conditions at the bottom, the environment seemed completely incompatible with life. Water pressure increases by 1 atmosphere every 10 meters. At the surface, your body experiences 1 atmosphere of pressure. At the bottom of the Mariana Trench, the pressure exceeds 1,000 atmospheres. Under those conditions, unprotected metal collapses. Glass shatters. Electronics fail. The human body would be crushed instantly. Temperature adds another layer of hostility. Near the trench floor, water temperatures hover just above freezing. There's no sunlight, no photosynthesis, no warmth. Energy sources appear scarce. Everything about the environment suggests emptiness. For much of the 20th century, this led to a confident scientific assumption: the deepest parts of the ocean were lifeless. Not unexplored, lifeless. A biological dead zone created by physics itself. That assumption shaped how scientists viewed Earth. Life, they believed, had strict limits. It needed light, moderate pressure, stable temperatures. Extreme environments might exist, but they were beyond biology's reach. The Mariana Trench became the ultimate boundary. A natural line separating the living world from the inanimate. And yet, boundaries have a way of inviting challenge. In 1960, at the height of the Cold War and rapid technological advancement, 2 men descended into the trench aboard a small submersible called Trieste. The vessel was a steel sphere attached to a flotation tank, designed to withstand pressures no human-made object had ever endured. The descent took nearly 5 hours. Outside the small viewing window, darkness swallowed everything. Instruments creaked. The hull groaned under stress. Communication with the surface was minimal. There was no rescue plan. If something failed, there would be no escape. When Trieste finally reached the bottom, it rested on soft sediment. For a moment, clouds of disturbed material filled the water. Visibility was near zero. Then the sediment settled. What the crew reported challenged decades of scientific certainty. They observed movement. Not dramatic, not fast, but unmistakable. Something alive, moving deliberately along the seafloor. Although later interpretations debated exactly what was seen, the impact of that report was undeniable. The deepest place on Earth might not be empty after all. That single possibility forced scientists to reconsider their assumptions. If life existed there, even in the simplest form, then the limits of biology were far wider than previously believed. But one descent was not enough. Technology at the time was limited. Cameras were crude. Missions were rare and expensive. For decades, the trench remained mostly out of reach, its secrets hinted at but not fully revealed. Meanwhile, ocean science continued to evolve. Researchers began studying life in other extreme environments: hydrothermal vents, polar ice, acidic lakes, radioactive waste sites. Again and again, life appeared where it shouldn't exist. Each discovery chipped away at the idea that the Mariana Trench was sterile. By the early 21st century, advances in materials science, robotics, and deep-sea engineering reopened the door to the trench. New submersibles could dive deeper, stay longer, and capture clearer images. Sensors could measure pressure, chemistry, and biological activity in real time. With each mission, scientists weren't just asking what lived there. They were asking something more fundamental. What does it mean for a planet to be alive? Because the Mariana Trench is not just a hole in the ocean. It is a product of Earth's internal forces, a place where the surface world connects directly to the planet's restless interior. It is shaped by movements that occur over millions of years, far beyond human timescales. To understand why scientists keep returning to this place, why they risk time, money, and technology to reach it, we have to understand how the trench itself was created. And that story begins far below the ocean floor, where Earth is constantly reshaping itself. The Mariana Trench did not form because the ocean is deep. The ocean is deep there because the Earth is restless. Far beneath the surface, long before humans existed, the planet was already in motion. Earth's outer shell is not a single solid piece. It is fractured into massive plates, each one drifting slowly across the planet's surface. Most of the time, this movement is imperceptible. A few centimeters per year. Barely the speed at which fingernails grow. But over millions of years, those small movements reshape the entire planet. The Mariana Trench exists because two of these plates collided. The Pacific Plate, one of the largest and oldest on Earth, moves westward. As it approaches the Philippine Sea Plate, something unusual happens. Instead of pushing upward to form mountains, the Pacific Plate bends. It sinks. This process is known as subduction. The older, colder, denser plate slides beneath the lighter one, disappearing into Earth's mantle. As it descends, it drags the ocean floor downward with it, creating a long, curved depression. That depression deepens over time. Unlike mountains, which rise above the surface and erode, trenches deepen silently. Water fills the space instantly. There are no cliffs visible from above, no obvious signs at the surface. From a ship, the ocean looks the same. Calm. Endless. But beneath that calm surface, the seafloor drops away sharply. The Mariana Trench stretches for more than 2,500 kilometers. It is not a single point, but a massive geological feature carved by continuous motion. Challenger Deep, its deepest point, lies at the heart of this process, where the Pacific Plate sinks most steeply. This constant movement generates enormous stress. As the plate bends and slides downward, it releases energy in the form of earthquakes. Many of the most powerful seismic events on Earth originate near subduction zones like this one. But earthquakes are only part of the story. As the plate descends, it carries water trapped in minerals deep into the mantle. Under intense heat and pressure, this water is released, lowering the melting point of surrounding rock. That molten material rises, feeding chains of volcanoes far away from the trench itself. In this way, the Mariana Trench is connected to volcanoes, islands, and even continents thousands of kilometers distant. What happens at the bottom of the ocean influences the surface world. For scientists, this makes the trench more than a curiosity. It is a key to understanding how Earth recycles itself. Old crust is destroyed here, while new crust is created elsewhere. The planet renews its surface through this slow, relentless cycle. Yet the same forces that shape the trench also create one of the most extreme environments on Earth. As depth increases, pressure rises dramatically. At the bottom of the trench, the weight of the water above exerts a force of more than 100 megapascals. This pressure changes the behavior of matter itself. Chemical reactions occur differently. Proteins fold in unusual ways. Even water behaves slightly differently under such conditions. Temperature adds to the challenge. While the surface ocean absorbs heat from the sun, the deep ocean remains cold and stable. Near the trench floor, temperatures remain just above freezing year-round. There is no light, no seasons, no weather. Energy, the fundamental requirement for life, is scarce. Photosynthesis is impossible. Any ecosystem that exists must rely on materials sinking from above or on chemical energy released from Earth's interior. For a long time, scientists assumed this combination of factors made complex life impossible. At best, they expected simple microorganisms, clinging to survival at the very edge of biology. But as research expanded, another realization emerged. Extreme pressure does not merely destroy. It also preserves. Organic material decomposes more slowly. Movement is reduced. Time itself seems to stretch. This raised new questions. Could life in the trench be ancient? Could it evolve differently, isolated from surface ecosystems for millions of years? To answer these questions, scientists needed direct observation. Not assumptions. Not models. Real data. Modern submersibles were built with this goal in mind. Unlike earlier vessels, they could descend repeatedly, remain at depth longer, and carry sensitive instruments. Robotic explorers followed, capable of reaching depths too dangerous for humans. With each descent, sensors measured salinity, temperature, pressure, and chemistry. Cameras scanned the seafloor. Traps collected samples. What returned to the surface challenged expectations once again. The trench was not uniform. It was layered. Zones formed based on depth, pressure, and available nutrients. Each zone supported its own form of life, adapted precisely to its conditions. The deeper scientists looked, the clearer it became that the Mariana Trench was not simply an extreme environment. It was a functioning system. And that system was far more complex than anyone had predicted. Understanding it would require not just geology and physics, but biology, chemistry, and time. Lots of time. Because the most surprising discoveries were still waiting at the very bottom. As exploration technology improved, the Mariana Trench stopped being just a theoretical extreme and became a place that could be studied directly. What scientists found there was not dramatic in the way movies imagine it. There were no giant monsters or violent movements. Instead, there was something far more unsettling. There was stability. Life in the trench moves slowly. Energy is precious, so nothing is wasted. Many animals have soft, translucent bodies that flex under pressure instead of resisting it. Hard shells, common in shallow waters, are rare at extreme depths because rigidity becomes a weakness when pressure is constant. Eyes, when they exist at all, are small and simple. In total darkness, sight offers little advantage. Instead, organisms rely on touch, vibration, and chemical signals. The ocean floor becomes a landscape felt rather than seen. Some creatures feed on organic debris that drifts down from the surface, the slow, steady rain of dead plankton, fecal matter, and microscopic particles. Others depend on bacteria that convert chemicals from the sediment into energy. These bacteria form the base of a food web that operates entirely without sunlight. This discovery alone reshaped biology. It demonstrated that life does not require light, only energy and stability. The trench revealed a version of life adapted not for speed or competition, but for endurance. As samples were brought back to the surface, scientists discovered organisms with biochemistry unlike anything seen before. Proteins structured to function under immense pressure. Cell membranes reinforced to remain flexible rather than rigid. Genetic adaptations that would fail instantly at the surface but thrive in the deep. But alongside these discoveries came an uncomfortable realization. Human presence had reached even here. Microplastic fibers were found in sediment samples. Chemical traces from industrial pollutants appeared in organisms living nearly 11 kilometers below the surface. These materials had not been dumped directly into the trench. They had traveled slowly, carried by currents, sinking over decades. The deepest place on Earth was no longer untouched. This forced scientists to rethink the idea of isolation. There is no truly separate environment on the planet. What happens at the surface eventually reaches even the most remote depths. Yet despite this intrusion, the trench continues to offer insight into questions far larger than pollution or exploration. The conditions found in the Mariana Trench closely resemble environments believed to exist on other worlds. Beneath the icy crust of moons like Europa and Enceladus, vast oceans may exist in complete darkness, under immense pressure, powered not by sunlight but by chemical energy. By studying life in Earth's deepest trench, scientists gain clues about how life might exist beyond our planet. In this way, the Mariana Trench becomes more than a feature of Earth. It becomes a testing ground for understanding life in the universe. And that is why scientists keep returning. Not because the trench is dangerous, or mysterious, or dramatic, but because it challenges assumptions. It shows that life adapts, persists, and endures in ways we never expect. It reminds us that Earth is not fully mapped, not fully understood, and not finished revealing its secrets. The deepest place on our planet is not empty. It is alive. And in its darkness, it quietly tells the story of a world still in motion, and of life that refuses to disappear. If you enjoy exploring the hidden side of our planet, consider subscribing to the channel. Every week, we dive into places most people never see.